Good morning, Jörn Helbert. Thank you so much for speaking to me this morning. I always ask people where they are and what the weather is like. So you are no exception. So Jörn, where are you this morning and what's the weather like?
Yeah, good morning. I'm in Berlin, Germany at the DELA Institute for Planetary Research, and it's a cloudy gray morning in Berlin, and we start to get into autumn.
I know, you can feel it, can't you? I find it with the days going, the nighttime is coming in very fast. And of course, I think, is it today that we have the autumn equinox? So we have 12 hours of light and 12 hours of darkness today. So from now on, it's going to start getting darker every day. But anyway, that's not what we're here to talk about. We're here to talk about Venus and your association with all things Venus and DLR's special Venus chamber. So please tell us everything about the upcoming missions Veritas and Envision and your association with them and how you are involved in all of that.
Yeah, I mean, it's a really exciting time. I mean, we have been fighting to get missions to Venus for a really, really long time. I mean, I've been involved with the Veritas mission for 12, 13 years. And we've been trying to get that. And Envision is more or less the same, different iterations. And it's surprising. I mean, Venus is our next planet. It's almost the same in size to Earth, and we know so little about Venus. And it has been also, I mean, it has been visited by Venus Express recently. There's still a Japanese mission there, but otherwise it has been really neglected in terms of missions. Partly, I think, because people had the feeling we know everything about Venus, which always was really puzzling to me, because I was thinking, actually, I have a long list of things I don't know about Venus. And, but actually, in recent years, with the exoplanet people and discussing with exoplanet people and why their model are always very leaning towards Earth-like planets, and talking to them, so yeah, if you can give us this parameter for Venus, we can tune our model. It's like, I don't know. I don't know this parameter. I don't know composition. I don't know what is on the surface of Venus. And I think this kind of people started to realize actually we do know really little about Venus. And there's a lot of just fundamental things we don't know. And I mean, we here in Berlin, we've been working on Venus Express. And we've been these strange people. I mean, Venus Express was mainly an atmosphere mission.
Yeah.
And we were these strange people that said, well, actually, there is actually this really small range around 1 micron where you should be able to see the surface. And so we used that, and I had the impression when we were proposing that together with colleagues from Italy and France, that no one was really believing that there was much coming out. And in the end, it was very successful. And even so, Venus Express was never, or the instruments were never designed for that. I mean, we could show there were variations on the surface. We could show that there's been volcanism in the recent geological past of Venus. So it could really make advances for surface science of Venus. And that is kind of, I think, at least I like to believe, is what also helped us with Veritas and Envision, because we could basically prove there's a way to get a surface composition map from Venus that does not require hundreds of landers, but it's actually something you can do from orbit. But of course, the problem was from Venus Express, we could basically say, well, that region looks different from that region.
Yeah.
But we could not actually say what it is. We could just say that is something different from that one. And the problem with that was, since it's a very strange range, we use 1 micron and we look at emissivity, because we basically look on the night side and we see the surface glowing. And we basically see the glow of the surface through the clouds from orbit. So as you can imagine, it's a very, very tiny signal. Because yes, the surface is 450 degrees, but it's not incredibly, I mean, it's hot, but I mean, to get a strong signal, there's not much. And so this is something that you normally don't do in the lab. And so basically triggered by Venus Express, we set up a lab in Berlin that allows us to do exactly measurement in that range and basically prove to people that, yes, it's a strange technique and it's not something you would normally do, but actually it's useful and it would actually allow you to tell something about surface composition of Venus to a degree that people were not expecting. And so basically, combining this, having the Venus Express data showing that in principle it's possible, having the lab data say actually it's not just possible, but you could actually learn a lot about it, then really allowed us to propose instruments that are now both in Envision and Veritas, and basically also push both missions to say, actually, now we are at a point where we have new instrumentations that actually allow us to learn something new. So now is the time to go with this new instrumentation and get new missions done.
Fantastic. It is a fascinating planet, isn't it? Like, you know, I've reported
it is.
You know, for kids shows and stuff like that. It's a crazy planet. So it's great to know that there are 2 missions going back. So have preparations started already for Veritas in your lab, or is it still just in the build phase and sort of the planning phase?
Well, I mean, both. I mean, we already built a prototype of the instrument that we want to fly. So to just show that in principle, I mean, not only that the principle works, but also the principle of the instrument works, which we can actually link to our chamber. So we can actually show that you can do something. And now we're basically in the real detailed planning phase. So now that we are selected, now it's make details plan for how do we actually get from this prototype now all the way to something that will be on the spacecraft and fly to Venus. All the testing, everything involved. And it's interesting because, I mean, we do this for 2 missions. So we have a kind of experience of both NAS and ESA, which both have their slightly different approaches, which is challenging, but also interesting to work with both teams. It's also nice because now all the teams, and there's a third mission, there's Da Vinci, which is a lander mission or a descent probe. And it's nice now because we're not in competition anymore. So suddenly we can actually talk to each other and really talk about, okay, you go first, but your data will help. I mean, Veritas goes first, and Veritas data will help make Envision better. So now it's really a nice time because suddenly all these teams come together and think about what we can do together. On the other hand, it's a bit challenging, of course. I mean, since with the COVID situation, everyone is working from home or cannot travel. So for Veritas, there's a lot of people I never met in person. I mean, I've seen them through the screen, but I never actually met them in person, which is a strange situation. And in a way, it's similar to Envision. There are some people that I only know from the picture on the screen, but I actually never met them in person. I mean, this will change now, but it was an interesting challenge to get this study phase done when you're actually not allowed to meet, and everything has to be done via Zoom or Webex or whatever meeting.
Brilliant. Well, I'm really looking forward to it. I mean, Venus is one of my favorites as well. So best of luck with Veritas and Envision, and we look forward to seeing what kind of results you get back. So thanks for joining us today, Jörn, on our daily briefing session.
Thank you so much.